So let us make the calculation of the variance and standard deviation for project A, and then we will do for project B. So write down heading calculation of variance and standard deviation, comma, of year 1 cash flow, comma, for project A. So friends, what we will do over here, column number 1 will be probability, column number 2 is cash flow. Let us assign x variable to it. Probability into x, with that we will compute the x bar, then we will compute x minus x bar, and the last column will be x minus x bar whole square into probability, summation of that is variance, and under root of the same would be standard deviation. This is the way we are required to show the presentation of answer. So friends, over here, in case of project A, we understand that there are 10% chances cash inflow is 8,000, 20% chances it will be 10,000, and 70% chances it will be 12,000. So then what we will do, probability into x. So 8,000 into 0.10, 10,000 into 0.20, 12,000 into 0.70. This is the way the x bar can be calculated. So it is 800, 2,000, 8,400, so x bar is 11,200. So now friends, x minus x bar, so it is 8,000 minus 11,200, that comes to 3,200 negative. 10,000 minus 11,200, so it is 1,200 negative. 12,000 minus 11,200, it comes to 800 positive. This is the way we will compute the x minus x bar. Then x minus x bar whole square. So basically to remove the effect of negative, we make square into probability, that is making a kind of average. So square of 3,200 into 0.1, it comes to 10,24,000. Keep that value directly into m plus negative 1,200 square into 0.20. It comes to 2,88,000. Again keep it directly into m plus square of 800 into 0.70. That comes to 4,48,000. So summation of that is variance. Variance is 17,60,000. Dear students, as far as the variance is concerned, it is calculated in square term. This is what we have, a kind of unit. The question further says that so you are required to make the computation of the variance and also the standard deviation. So standard deviation is under root of the variance. So it is under root of summation probability into x minus x bar whole square So it is under root of 17,60,000. So the answer comes to 1326, 1226.65. This is the way we are required to make the computation of the variance. Sorry, this is standard deviation 1226.65, that is measured in the unit term, that is in the rupees term over here. Whatever we have done for A project, the same thing we are required to do for B project. So heading right down, calculation of variance and standard deviation of project B, comma, for year 1. This is what we are required to do. Again, the same sequence is required to be followed. Column number 1 is probability. Column number 2 is cash flow. Let me assign y variable to it. Probability into y minus y bar, y minus y bar whole square into probability, and summation of that is variance. Sometimes students are having a question to ask me that, sir, x minus x bar total should be 0. Why it does not come 0 over here? Friends, basically there are two kind of information that we have. One is given a name as the probability distribution method, and another is other than the probability distribution method, wherein you may be provided with the sample data for assessment or you may be provided with the population data for assessment. So whenever the sample data or population data is given to you, in that case x minus x bar total would be 0, but not over here. So just in case you have that question, then in that case this is the answer that we have. So let us see how to do answer for project B. So in that case, there are 10% chances cash flow will be 4,000. There are 15% chances cash flow will be 20,000. 75% chances cash flow will be 16,000. So 10% into 4,000, that comes to 400. 15% chances it is 20,000. So it is 3,000. 75% chances is just 16,000. So it is 12,000. And based on that, we will compute y bar. 400 plus 3,000 plus 12,000. That comes to 15,400. Y minus y bar. 4,000 minus 15,400. So 11,400 negative. 20,000 minus 15,400. So positive 4,600. 16,000 minus 15,400. So it comes to 600 positive. Now y minus y bar whole square into probability. So now it will be negative 11,400 square into 0.10. Square of 4,600 into 0.15. Square of 600 into 0.75. So answer will be found like this. Square of 11,400 into 0.10. I keep the value in the memory plus, and the amount is 1 crore 29 lakhs 96,000. Square of 4600 into 0.15. Again M plus 31,74,000. Square of 600 into 0.75. 2,70,000. So total of all of them is variance 1 crore 64,40,000. This is the variance. Now this is the variance of year 1 cash flow. Now standard deviation. Standard deviation is under root of variance. So under root of 1 crore 64,40,000. Now friends, just for understanding, friends, this answer of the square root can be calculated by one more method than simply the way we do the square root. It is like this. One is that say you do square root of this directly and it comes to rupees 4054.63. Now other thing is that say what you can do, square root of 1 crore 64,40,000. It's under root. Now what you can do, you can cancel two zeros from this and you multiply final answer with 10. Why? Because root of 100 is 10. You cancel another two zeros and you multiply final answer with 100. And then you do under root of 1644 and that answer is multiplied with 100. This is the way you can have a kind of shortcut working. If at all the figure is in million, trillion, like that. If it is like that. So root of 1644. So 40.54 something I am getting into 100. So the answer is finally 4054.63. This is the way we can calculate the answer. So friends, over here in this question, as per the given information, there are two things that say we had to calculate. One was variance that we have done for project A and project B, and then standard deviation. This is the way the calculation is made for both of them. Now, of course, the question is over. However, I am extending certain, that is, I am giving some more explanation to you only for the purpose of understanding. And this explanation is not forming part of this answer. This is only for the purpose of understanding. In order to give explanation, I am taking some simple values so that it will be easy for us to have a kind of conversation. Suppose the X bar, that is the mean cash flow, is rupees 10,000 at the end of the first year, and let us say that the standard deviation of that is an amount of rupees 2,000. Okay. Now I am doing one more working, X bar plus or minus 1 standard deviation. Why? I just explained that to you. So 10,000 minus 1 into 2,000 and 10,000 plus 1 into 2,000. So in that case it is 8,000 and over here it is 12,000. X bar plus or minus 2 standard deviation. So 10,000 minus 2 into 2,000. So it is 10,000 minus 4,000, that comes to 6,000. And on the other hand, again 10,000 plus 2 into 2,000. Why I am doing it, I just explained that to you in 2 minutes. And again I repeat that, say this is only for understanding, not forming part of answer. x bar plus or minus 3 standard deviation. So it is 10,000 minus 3 into 2000. So it is 10,000 minus 6,000. That comes to 4,000. 10,000 plus 3 into 2000. So 10,000 plus 6,000. That comes to 16,000. This is what I have calculated. So we can say that, say, the x bar plus or minus 1 standard deviation is 8,000 to 12,000. X bar plus or minus 2 standard deviation is 6,000 to 14,000. X bar plus or minus 3 standard deviation is 4,000 to 16,000. This is what I have calculated. Now friends, the term standard deviation is basically a term which has been derived in statistics. The term mean is again a term which has been derived in statistics. So over here, in analyzing the risk in the capital budgeting decision, we take help of the standard deviation, we take help of the statistics. Statistics says something like this. We know that, say, in case of normal probability distribution method, we have this kind of bell-shaped curve diagram, wherein exactly in between value is indicating x bar. X bar is mean value, that is an amount of rupees 10,000 in the example which I have taken over here. Friends, over here it is considered that, so whatever the mean value has 50% probability, there are 50% chances that the cash flow will be 10,000 rupees. That is what they have told us and which we have accepted. Actual result may deviate from the expected result. To what extent it can deviate is measured by standard deviation. Over here, the kind of explanation which they have given is like this. X bar plus or minus 1 standard deviation. So we understand that, say, over here, cash flows of the project will fall in between 8,000 and 12,000. Cash flows of the project will fall in between 8,000 and 12,000. For that, say, there are 68% chances. That is what it says. This is the kind of conclusion that, say, they already have drawn by making number of experiments. There are 68% chances that the cash flow will fall in between this range. X bar plus or minus 2 standard deviation. That is, over here in this example, we understand that, so the cash flow will fall in between 6,000 and 14,000. 6,000 and 14,000. For that, say, there are 94% chances. So how this 94% comes? For that, say, we can say that, say, the kind of experiments that, say, they have, that is, say, that they have done, based on that, say, they have provided this value to us. X bar plus or minus 3 standard deviation. So over here we understand that, say, the cash flow will fall in between 4,000 and 16,000. For that, say, there are approximately 99% chances. This is the conclusion that, say, they have drawn. Means Higher the volatility, higher the risk. If at all the volatility is more, it means that the risk of the project is more. This is what we understand. So standard deviation is considered to be the measurement of the risk. Higher the standard deviation, it means more risk. Lower the standard deviation, it means less risk. If at all I draw two diagrams over here, let us say it is P and it is Q. These are the two projects. In case of the P project, the volatility is like this, and in case of Q project, the volatility is like this. Then which one is having more risk, P or Q? Correct. We understand that the Q is having comparatively more risk. We understand that the more volatility is indicating more risk and vice versa. This is the kind of the understanding that we have over here. In this question, nowhere we are required to write any of these things. Over here, this is basically a rule that they have followed or that they have made is called empirical rule in statistics, and based on this empirical rule, they have provided these kind of estimates. Now friends, answer of the question is over. However, I just want to dictate a note to you for this. Okay, so write down a small note for this answer only for understanding purpose. First point, we understand that mean value, comma, expected value has 50% chances of outcome. Full stop. Second point, standard deviation is indicating deviation of actual value from expected value. Full stop. Standard deviation, in bracket I am writing SD, is measuring volatility of actual value from mean value. Full stop. Third point, higher SD means more risk and vice versa. Full stop.